All right, so good afternoon. This is David Raymond, and this is the Virginia Cyber Range weekly workshop. Today we're going to be talking about hands-on reconnaissance and scanning. So last week we discussed this whole notion of reconnaissance, why you do it, when you do it, how you do it, and then we touched a little bit on network scanning. Didn't really do much of that because today is our opportunity to do some of that in a hands-on way. So we'll do a little hands-on recon, not a whole lot, but a little bit, and then we'll dive into network scanning. So if you want to participate today, then you should take a screenshot of this slide or write down this invitation code. So what you'll need is a Cyber Basics 2018 environment in the Virginia Cyber Range, at least if you're going to go sort of work alongside me as I go through this hands-on exercise. And so the invitation code that you'll need is in red there to join a course that I have set up, or if you already have an account, or if you have an account, if you have a instructor account, you can create your own Cyber Basics 2018 environment in one of your accounts, one of your courses, I should say. If you do need the invitation code, most people participating in this are listening to it after the fact. So invitation code provided here expires on the 29th of January. So if you're listening to this after January 29th and you need an invitation code to get into this Cyber Basics 2018 environment, then please send an email to support@virginiacyberrange.org, refer to this workshop and what you need, and we'll get you a new invitation code. There's also a hands-on exercise that I'm going to be using during this session. It's referred to in the last bullet here, so Reconnaissance and Network Scanning Lab, that's in the Cyber Basics courseware on the Virginia Cyber Range courseware repository. So I encourage you to if you're gonna play along, I encourage you to go grab that document. Okay, I'll show this slide again one more time before I dive in so you can make sure you capture this info. Weekly workshops, coverage of cybersecurity education topics every Tuesday at 1 p.m. We record them and share them on the virginiacyberrange.org website. Under the community tab, you'll see a weekly workshop button that you can click on to find the whole library of weekly workshops. There's probably a dozen or more out there now. If you'd like to see a particular topic, then please send an email to me directly or send an email to contact@virginiacyberrange.org and we'll add your recommendation to the list. All right, we'll start with some recent news. First one here is reported in Wired magazine last week. So this would have been Wednesday, I think, of last week. Hack Brief, an astonishing 773 million records exposed in monster breach. So this is a collection, this is based on a collection of files that a security researcher amassed and parsed and deduplicated and came up with this list of compromised records, so not necessarily compromised passwords, but what he found in it was 773 million email addresses, 21 million unique passwords. So in this kind of a situation, some of the passwords may have been he says 773 million email addresses, 21 million unique passwords. So, you could have this situation where the same password is used by multiple people, and that happens often when people use bad passwords like password or 123456 or whatever. You could imagine that multiple people have that same password. My guess is that for the rest of these 773 million email addresses, the password was not compromised, right? So some subset of the email addresses were account names where the password was compromised, and then the rest of them, lots of them were probably not compromised. And then the next story I have listed there, this was on January 19th, so 3 days later. Brian Krebs, who's a well-known security researcher, I refer to him often. You probably heard me say his name. He has a great blog called KrebsOnSecurity.com. He reported that the mega breach is years old. So this is old data that's kind of being rehashed, and that's not surprising, I guess. But 773 million email addresses along with 21 million unique passwords, that's a lot, right? So So where does all this come from? Well, we know that that websites are compromised, or different online systems are compromised on a regular basis. And what an attacker will do is, once they've compromised a website and grabbed the grabbed whatever credentials they can grab, they will try to crack as many passwords as they can. So they're going to get some subset of the email addresses with corresponding passwords. And then those will often be for sale for a certain period of time. And the fresher it is, the more it's worth, and those are sold on the dark web. And on one of these workshops, I suppose we could have a discussion about the dark web and what that's all about. Anyway, so those credentials are sold, for some period of time, and then after a while, when it's no longer worth anything, then the credentials will get dumped to various places on the internet. One of those places is a place called Pastebin. That's a pretty popular landing spot for old credential dumps, and so the reason that people should care about this, the reason that your students should care about this, is because this is why we don't reuse passwords, right? Because if you use the same password on your Facebook account that you do on your bank, and then your Facebook account gets compromised, you may never know that your Facebook account got compromised, but somebody has gotten your username and password for that account, and then they've tried to sell it for a while, and now it's no longer worth much a few months later, so they throw it in Pastebin. And so now those credentials are available, and they're often shared with information about where they came from. So the information, it may say, hey, this came from Facebook, or often it doesn't have any of that information. It's just known credentials. But what attackers will do is they will grab those credentials and they will do what's called a credential stuffing attack. So what they'll do is they'll use software that will go to particular websites, and they'll try this whole list of usernames and passwords that have been grabbed from other sites, and the expectation is that some of those username password combinations have been used multiple times on different websites, because that's what people do, right? They can't remember their or they can't remember more than one great password, so they use the same one everywhere. Bad idea, because of this kind of thing, right? These credentials get compromised, and all of a sudden, somebody's using the login for your Facebook account to log into your bank, and then that's not good. So there's actually a place where you can go if you want to see if your credentials have been compromised in a data breach. It's this website, haveibeenpwned.com. And I've spelled it out here, so you might want to take a screenshot. PWNED. That's kind of a hacker word. Owned is, have I been owned? Have I been compromised.com is what that means. If you go there to that website, do it real quick just for fun. Have I been pwned? This site, whoops, wrong button, obviously. This site is maintained by a security researcher who basically he sucks in all these credential dumps in Pastebin and other places, and he adds them to this database that he has, and then you can type in your email address. So one of my email addresses is this, and it comes back and says, oh, hey, good news, no pwnage found. I certainly suggest that you try this out. Type in your various email addresses and see if your password has ever been compromised. do this. Oh no, I've been pwned. So this is an old, this is my VT email address, and it's something I've had for 15 years or so, and used it to create accounts on a lot of different sites, and maybe didn't use great passwords many, many years ago on some sites that I didn't think were very important. So this says, okay, I have a password that's been compromised, and if I did some digging, I could see what password was used. I look at it and I say, yep, that's a password I used many years ago on maybe 2 sites or 3 sites, or I don't know, maybe 7 sites, looks like. Anyway, interesting information, interesting thing to point your students at as you talk about passwords and credentials and that kind of stuff. Okay, so that's credential dump from last week, and nothing new. This happens often. More recent news. So this top story: Google Play malware uses phones' motion sensors to conceal itself. This is an Ars Technica story, pretty good security website, and so what this malware does is it doesn't deploy until it senses motion in the phone. It doesn't deploy until it senses motion in the phone. And of course, modern smartphones have accelerometers and et cetera, and they know when they're being moved, right? So that's why when you pick it up, the screen will come on, because it knows that it's been lifted up, and the expectation is that you're going to want to look at it. So why would the malware only deploy when the phone is moved? Well, because it's sort of described in these bullets. Emulators used by security researchers and possibly Google employees screening apps submitted to the Play Store are less likely to use sensors, right? So if somebody is examining the piece of software to determine if it's malware, they're often doing that in an emulator, and the emulator does not include the accelerometers and things. The computer doesn't have that. If the emulating device, which is usually a computer sitting somewhere, doesn't have all those accelerometers and gyroscopes and compasses and et cetera. So the emulator just ignores all those as no input, and so to the software, it looks like the device is not moving. And this is not surprising, actually. So this has been done by malware developer. This kind of thing has been done for years by malware developers. What they'll do is, for example, they will, it's historically what they've done is they have, the malware has detected whether it's running in a virtual machine or not. And why would it do that? Well, obviously 10 or 12 years ago, malware was generally deployed to real computer systems, but it was examined on virtual machines because security researchers don't want to accidentally infect their own machine. They want to infect a virtual machine, because when they're done examining a particular piece of malware, then they can sort of delete they can roll back the virtual machine to the clean state that it was in before it started examining that piece of malware. So malware would not activate if it could detect that it was running in a virtual machine. So this is just sort of an evolution of that approach, but I think it's kind of interesting. So 2 Google Play apps recently caught would activate the payload only when motion was detected first. Otherwise, the Trojan would remain dormant. So that's to prevent people from who are researching to determine if a particular piece of software has malware involved in it or not. It's to prevent those people from discovering that there's malware. So second bullet there: France fines Google $57 million for a European privacy rule breach. And this is related to Gdpr, which is European Union requirements for privacy, for data privacy. And so this is pretty significant, right? $57 million. Of course, to Google, that's pocket change, but still, it's a lot of money, right? $57 million for this GDPR violation. And GDPR is this very strict set of privacy laws imposed in May of 2017 and applied to European Union, and then you might say, well, how is Google fined by the European Union? Well, GDPR applies to EU organizations and to companies that do business in the EU. So obviously Google does business in the European Union, and so there's potential for them to be fined by the European Union. And GDPR, if you're familiar with this regulation or not, it might be interesting to look up and to discuss with students in the classroom. It is very strict privacy laws, and it has this requirement to very carefully protect any piece of data that can be sort of related back to a certain individual. And like in these workshops, we've probably talked before about personally identifiable information, right? Things that we consider to be personally identifiable include things like your name, your social security number, your bank account number, your passport number. There's a small handful of data elements that we say, this is personally identifiable, this could be traced back to an individual, these need to be very carefully secured. Well, GDPR has a much broader list of things that could be considered personally identifiable, even things like an IP address, right? Because your IP address could potentially identify who you are. And a MAC address, the medium access control address, the MAC address, hardware address of your network interface card on your computer or on your phone. Those things could be, sort of traced back to a particular individual. So those things under GDPR are considered personal information. So what does GDPR require? Well, it requires that the primary requirement is that any of that sort of data that's collected has to be collected with the approval of the person that the data is being collected from, right? So how the thing that you've probably seen that's an output of GDPR that maybe you didn't sort of relate to that is, since May of last year, there's been this huge number, just about every website that exists that collects any data about you, which most of them collect a whole bunch of data about you. They all added this new click-through that said, by using our website, you consent to whatever, your data being collected. And then if you want to read our privacy policy, then click here. And if you click into the privacy policy, then you'll see details on all the information that they collect. Most websites refreshed their privacy policy and imposed that click-through since May of last year when GDPR was enacted. And they also added these cookie notifications that say, by using our website, you basically agree that we can use cookies, and cookies are used to track user behavior. Cookies are files that are recorded, about your use of a website that's recorded on your own computer. I saw it part of a talk recently where the person said that 97% of Americans don't even know what a cookie is, but they all click through this thing because they want to get to the website they're going to. So that particular warning is particularly useless, but it's a GDPR requirement, right? So GDPR it certainly has advocates in the European Union because because privacy is becoming a big issue on the internet, and people want to make sure they have control over how their data is used. They want to make sure that data about them is used only in particular ways, and so GDPR provides some of those kinds of guarantees. What it also provides is this notion of a right to be forgotten. So what that says is that you can petition an organization to have them delete any records they have about you under certain circumstances. And I'm not going to go through all the circumstances, but basically the right to be forgotten requires that companies have mechanisms in place with which they can basically delete any recorded information that has been tracked, that they've gathered about any particular individual. And that is extraordinarily complicated, believe it or not. So that's an offshoot of GDPR that has business implications to any company that does business on the internet. So the interesting thing here is that really the GDPR hasn't been used to fine European organizations. In fact, if you read my last bullet there, embarrassing leak shows that the EU falls short of its own GDPR data law. And this was reported at the end of May of last year. And basically, the European Commission, that's the organization that ratified and enforces GDPR, they were breached, and they basically said that that they are not subject to the GDPR. they basically in this news story they basically said that we're not quite ready for it, so we're gonna delay our requirement to be subject to the GDPR, which that seems to me to be the height of hypocrisy, right? When they basically say, well, this is our rule, but we're not going to abide by it. So anyway, so the European Union hasn't levied any significant fines against any EU entities, but here they are fining Google $57 million. And so what some of the more cynical people are alleging is that, well, the GDPR really is just being used to limit U.S. Exposure in the European Union. They want to basically fine U.S. companies out of the market so that European versions of things like Google and whatever else will gain dominance, because GDPR can just keep fining and fining and fining until Google says, that's it, I can't take it anymore. I'm not going to do any business in Europe, kind of a thing. So anyway, that's might be worth an interesting chat with students. What do we think of this? What are the implications? And anytime you're talking about privacy and privacy policy, privacy law, GDPR is now sort of the gold standard in terms of the very strict set of privacy rules. And it's actually, we may see a similar thing in the US at some point in the not too distant future, because of people's concern for privacy and how their data is used. And most people had no idea until the 2016 election, and now we know about micro-targeting of political ads and all that kind of stuff. And so that's a little bit, Americans are a little bit more aware of this than they were just a couple of years ago. Okay, so today, network hands-on, network scanning hands-on, and then the next couple of weeks we'll talk about web application stuff. And I put this slide up previously. Here's the invitation code. You got to take a screenshot of this. And we're going to use the Reconnaissance and Network Scanning Lab out of the Cyber Basics courseware, out of the courseware repository. Okay, so now I'm going to close this. And I'm going to open, well, let me start with the hands-on exercise. Let's do that. So I'm already logged in. The range, and I'm going to, let's see, here's what I'm going to do. I'm going to click out of that. Whoops, did I get logged out? Perhaps got logged out. Sorry for the delay. Okay, and the credential for this environment is student. Oops, typed something wrong there. There we go. All right, and I'm going to pull up the Word document next to it here. Hopefully you can kind of see what's going on. And yeah, hopefully folks have a copy of this next to them that they can take a look at. Reconnaissance and Network Scanning Lab. So resources required. This exercise requires a Cyber Basics 2018 environment. Credentials are student. First thing we're going to do is a Whois Lookup. So for this exercise, you can use a web browser on your laptop or desktop computer. You can log into the Virginia Cyber Range. I'm just going to use my browser on my desktop here. And I'm going to go to https whois.icann.org. Icann is the Internet Consortium for Assigned Names and Numbers, and this is the organization that manages the worldwide distributed database that is the DNS, Distributed Name Service hierarchy. And so organizations who register, who allow you to pay them to register domain names, so there are several companies through which you can register domain names, companies like GoDaddy, for example. You can have an account there, you can register a domain, and then you can associate an IP address with a domain and et cetera. So first task here is related to Whois. Whois is a tool for querying databases containing domain registration data to determine ownership, IP address, and other information. It's an early Unix, Linux command line utility, is now mostly accessed from various web pages, such as viewdns.info or this whois.icann.org. A reverse Whois lookup can be used to find domains that are registered by a particular individual organization. So you can do this in both. Okay, so first I'm going to say, historically, you could do this in both ways. You could put in a domain and you could see who registered it. And you can also put in a name or an email address and see what domains they have registered. So you do this lookup both ways. So the first question here, who is Icann and why are they an authoritative source for Whois information? And again, they're the authoritative source because, and I was reading task 1A there, they're the authoritative source because they manage the worldwide DNS infrastructure. And it's an organization that is internationally run, essentially. It used to be a US entity, now it's internationally run. Okay, so task 1B, do a Whois lookup on the domain secretsquirrel.com. Secretsquirrel.com. And we're going to get results that are different than they would have been a year ago, and they're different because of GDPR, believe it or not. So first it asked me to confirm that I'm not a robot, so I'm clicking the I'm not a robot button. I wonder what robots do. Showing results for secretsquirrel.com. So this is interesting. Registering contact info, name is blank, organization is blank, mailing address is in Virginia, phone's blank, extension's blank, et cetera, et cetera, et cetera. And it says selected domain holder link at GoDaddy.com, Whois results ASPX domain equals secretsquirrel.com. So this doesn't answer the question, right? I wonder if this does. I'm going to try this. Control-C. It's basically referring me to GoDaddy. And why is it doing that? Well, that's where this particular domain is registered. And I'm going to do this and see if it gives me an answer. Still not a robot. So a year ago, if I would have done that same search, I would have gotten an answer. The answer would have been me. So I own secretsquirrel.com. It's a website, or it's a domain that I use for CTF challenges and stuff like that. And yeah, okay, here we go. Now I can get to me, right? So the reason that Icann no longer provides that information about me as it would have a year ago is because of GDPR, and Icann is afraid that that providing that information about me without my consent is a GDPR violation. So they're not going to provide the information that they would have provided, even though, again, they're the authoritative source for that information. They're not going to provide the information to people who come looking for it like I did, because I couldn't have authorized that release by Icann. So what Icann did do is they referred me to GoDaddy.com, and GoDaddy is releasing this information. So here's my name, here's my address, etc. It has, email, phone number, etc. And why can GoDaddy do this without worrying about GDPR? Well, because I registered the domain through GoDaddy. I have an account at GoDaddy, and I approved, basically when I after the middle of May of last year when GDPR was enforced, next time I logged into GoDaddy, I had to accept their new privacy documents, and I had to accept cookies. And so now I have essentially in that privacy policy, I gave GoDaddy authorization to provide information about my domain registration. And why is this information available? Well, historically, so back in the early days, the Icann and the Whois system readily provided information about the owners of various domains. And why did it do that? Well, back in the friendly internet, before people started creating it as a money machine and hacking each other, people contacted each other, right? So if I had a glitch on my web page, then I might get an email from somebody who did a Whois Lookup, and that might say, hey, your website this link is broken, you ought to go fix it. And I would, that would be information that I would want to get, right? I would want somebody to tell me that something is broken on my website. So information about domain registrants was freely available. Nowadays, when you register a domain, you can essentially obscure the registration information, and what the company will do is the company through which you register the domain, what they'll do is they will obscure that information, basically say that the domain is registered by them on your behalf, but they won't give your information, and that's to protect information about the owners of various domains. Of course, that costs more, so if you're going to do that, you got to pay for it. In this case, I don't care who knows that I own secretsquirrel.com. Again, it's just a toy website that I use for CTFs. And so, for me, I didn't pay the extra money for two reasons. First of all, I don't really care to have that information obscured. Secondly, I want to be able to use it for this exercise, so I just leave the information available. I do have other domains that are registered through GoDaddy, and that I keep private for various reasons. Okay, so to who's the domain registered? It's to register to me, David Raymond. A reverse Whois Lookup lets you search on the database for contact information, name or email address, and find domains registered to that person. So I'm going to go to this viewdns.info. I can do a copy paste here. Control C, Control V. What this says is look up someone you know who might have domains registered using either their name or their email address. Can you find any registered domains for raymond@vt.edu? So I'm going to go to this. I'm at viewdns.info, and I'm on the reverse lookup. There's all kinds of different things you can look up here. Reverse IP lookup, DNS report. So a reverse IP lookup, if you want to see what domain name is associated with a particular IP, you put in the IP address. Here I'm going to do a reverse Whois lookup. So I'm going to put in a bit of information about the registrant, raymond@vt.edu. And this is doing a reverse lookup based on information that I provided, and the fact that I have this domain registered isn't private information about me, so the viewdns.info website doesn't have any qualms about releasing this bit of information, and I happen to own the domain raymondlawoffice.com using my raymond@vt.edu email address. It's not my law office, it's a relative's law office, but anyway, it's, and Secret Squirrel doesn't show up because I didn't register it using, if you looked at when I pulled up the Whois information, I didn't use raymond@vt.edu account, I used a different account at GoDaddy to register that domain. So the reverse, the answer to 4C is raymondlawoffice.com. So that is domain lookups and such. And if you're sort of confused or not up to speed, then it's worth digging a little deeper into those various tasks under task 1. Okay, so Nslookup is the Linux and Windows tool for querying the distributed database that makes up the domain name system. So here we're going to look up not the registration information, but we're going to look up the mapping between domain names and IP addresses. So the database translates host names such as www.virginiacyberrange.org to IP addresses. This translation is necessary because the computer must have the IP address of the system, such as web servers that it communicates with. So we've talked previously about the DNS system and a little bit about how it works and why it's there. And if you're not comfortable with that, then I'd go back and look at that weekly workshop from last fall. So for this exercise, we're going to log into our Cyber Basics 2018 environment, which I'm already logged in here, and I'm logged in as using the username student, password student. It says open a terminal window and open the Linux man page for the Nslookup utility. Nslookup, whoops, man page. So remember, if you want more information about any particular Linux command, type in man space, name of the command. Man is short for manual, and this gives you all kinds of great information about that particular command, and you can scroll up and down in this. Use arrow keys or whatever. You use the mouse to scroll up and down. So Nslookup is a program to query internet domain name servers. It has 2 modes, interactive and non-interactive. Interactive mode allows the user to query name servers for information about various hosts and domains or print a list of hosts in a domain. So this is used Nslookup is used by system administrators or by network engineers as they're setting up their network and they're getting their DNS infrastructure set up, or maybe they're troubleshooting DNS issues in their organization. They can use, Nslookup is a great tool to make sure that your domain names are properly registered and they're associated with the correct IP addresses, and et cetera, et cetera. But this can also be used by somebody who wants to try to find out about, what IP addresses are active in your organization, what domain names are associated with them. There's lots of things you can do with DNS to identify, sort of map out an organization's network, and that's all part of reconnaissance, right? Get more information about about a target. So use Nslookup to find the IP address for virginiacyberrange.org. So to do that, type Q to get out of the command page here, and I'm going to say Nslookup virginiacyberrange.org. So the first bit of information here, this is not the answer to that question I just asked. This is the server. This is the DNS server that I'm querying. It's 10.1.112.2, and that particular DNS server happens to be a Virginia CyberRange DNS server. And remember, the DNS system is hierarchical, so that server would query other servers upstream, and eventually, if this answer wasn't held anywhere in that hierarchy, then the question would be asked of a root name server, who would then forward the request down to the entity that actually owns the particular domain name, and then the information would eventually get back to the original requester. So virginiacyberrange.org IP address is provided here, 23.185.0.1, and there's also an IPv6 address, 2620:12 alpha :8000:1. Okay, so how can you tell the difference between the IPv4 address and the IPv6 address? The IPv4 address is this, it's got 4 octets separated by decimal points, so 4 octets. So 8 plus 8 plus 8 plus 8 means a 32-bit IPv4 address, IP address. The v6 version is completely different in its format. It uses colons instead of dots, And I'm not going to talk much about IPv6 addressing. That's a whole other thing that we could talk about during one of these workshops. But it's easy to recognize as an IPv6 address because it's got colons instead of dots. Okay, dig is another more powerful tool for DNS database queries, only available in Linux and Unix systems. And so if I wanted to find out more about dig, I could do man dig, right, and get lots of information about it. It says, use dig at the command line to look up the IP address for virginiacyberrange.org. Did you get the same answer? So if I said dig virginiacyberrange.org, I would get, there's a little bit more information provided here, but essentially I would get this, under the answer section here, I get the same thing, right? 23.185.0.1. If I want to get the IPv6 address for that, I ask for that in dig. By default, dig is going to give me the IPv4 address. Use dig to conduct a reverse lookup of the IP address 8.8.8.8. And so up here, what does the -x command do in dig? So 2C here asks about the -x command, -x switch in the command line. -x does a reverse lookup. So if I go down here and say, dig -x 8.8.8.8, it's going to say, here's the answer section. 8.8.8.8 is Google public DNS.google.com. So 8.8.8.8 is a Google DNS server, and it's actually a very widely used DNS server. People often point their systems to 8.8.8.8 or 4.4.4.4. Those are both owned by Google, and they're DNS servers that you can point to publicly. So that's a reverse lookup, right? So this time I took the IP address 8.8.8.8 and I turned that into the fact that this thing is Google-public DNS-a.google.com, which I have highlighted here. Reverse lookup, looking up IP addresses, or I'm sorry, domain names from the IP address. A forward lookup, given a domain name, you get the IP address. Okay, network scanning and Nmap. So, so this section talks a little bit about the ifconfig command, right? So if we remember from our networking hands-on discussion, ifconfig gives me information about my own network configuration. So I'm going to type in ifconfig, and I have eth0. That's my primary interface on this virtual machine, and then I have LO, that's the loopback address, and that's used for internal networking. So the one that I care about is eth0, the primary network adapter, and here the internet address provided is 10.1.112.25. So this this hands-on exercise asks the student to write down the IP address of your virtual machine, and so here it's right here, 10.1.112.25. What is your subnet mask? Net mask is 255.255.240.0. I'm not going to talk a lot about subnet mask today. That's something to be covered in a networking session. How many unique hosts could you have in your subnet? How many IP addresses? And there's a way to look that up. Basically, it's a /20 subnet, so there's a particular number of hosts that you could have in that subnet. So now what I want to do is I want to identify the other hosts in my subnet. So I have a subnet, which is some group of computer systems. And there's a couple ways to identify all those systems. I can use this sort of formatting. I can say nmap-sn, and the SN switch basically tells Nmap to send a ping to each one of these devices to see if the device is awake or not. Nmap-sn, and then first IP address in the range and the last IP address in the range. So I don't know the first IP address in the range and the last IP address in the range. I could actually derive that from my own IP address and my subnet mask. So I know that I have a particular IP address. I know that I have a /20 subnet, and there's various websites I could go to where I could put that information in and it give me the first and last address in my subnet. So it's sort of basic binary math that you would have to do if you took a graduate class in computer networking, for example, or an undergraduate class. I'm not going to do that because there's a way easier way to do this. I don't have to know the first and last address. I just have to know that I have a /20 subnet, and I'm telling you that right here. So in order to discover all the systems in my subnet, I'm going to follow this syntax: nmap, nmap -sn, and my IP address is 10.1.112.25. And I actually added in an additional -n there. And I think that's going to make my scan a little bit faster. Whoops, I forgot to put in the /20. I think that's going to speed up my scan. What that tells Nmap is not to do a host name lookup on the IP addresses that it identifies, because then it spends a bunch of time doing DNS lookups that are unnecessary. I don't know, maybe that won't speed me up any. You can do this command that's given here. It'll probably work just as well. So nmap -sn, then your IP address /20. Again, that's because you're in a /20 subnet. And this should enumerate each of the IP addresses that are in this subnet. So these are the other systems that I can touch directly from my virtual machine. By touch, I mean get in contact with over the local internet, local network. And so what this asks you to do, question number 1 here, use the nmap command to discover all hosts in your subnet. Write down the full nmap command that you used. And so that's just, in my case, it's this, right? And then it says, then the next question is, which IP addresses besides your own did you discover in your subnet? People send me stuff, okay. So these are all the IP addresses that I discovered. So 112.25, these are all going to be 10.1 addresses. 112.25, well, that's me, right? So I identified myself. 114.154, 120.199, 125.25. Okay, so I would list those IP addresses here, and then it says port scan. Our next goal is to find other systems that are running in your subnet. So these are potential targets, right? So if I was an attacker and I got access to a device in a network, I could do this kind of a scan that would identify all the other systems in this leg of the network. And in this case, there are 4 systems. In some cases, there could be hundreds or thousands of systems. But that's, for an attacker, that's gold, right? Now I know what the systems are, and shut this off. Hopefully that'll. Okay, so so now it says. Now do an Nmap scan with no flags to scan each host. Okay, so now I want to say Nmap, I'm going to do this -n thing, and I'm going to go 10.1.114.154. So now I'm going to do an Nmap scan on each of these hosts, and this is going to tell me which ports are open on that host. And if you recall our discussion of networking, a port is something that you can connect to over the network. So for example, this host has port 22 open, that's SSH service. So I could say SSH 10.1.114. Now I'm trying to connect to that host. Okay, and it denied me. Kicked me out because I don't have the right credentials to contact that host. Okay, so that's good information. The other thing that's open on this device is port 80, which is HTTP. Okay, so what can I connect to HTTP with? Well, I can pull up my web browser, And normally with a web browser, you type in a domain name, right? Like www.google.com. In this case, I'm going to type in the IP address, 10.1.114.154. Okay, I can always use an IP address in a URL bar if I want to. Oh, and what's this? This is interesting. This is an Apache server, and it's got, so this looks to me like it's a poorly configured Apache web server. It's got this file called hello.html, which has got, I don't know, looks like a recipe for something. Preheat oven 300 degrees, beat egg yolks. Refrigerate until custard is set. I don't know, what's this? I don't know, custard. Interesting. Oh, and then it's got recipe, which is, okay, this is the same recipe, right? It's very interesting. And then it's got a folder called /temp, and temp has in it, oh, the Apache 2 Ubuntu default page. So this is a misconfigured or not fully configured HTTP server running as a service on a host in the Virginia Cyber Range Cyber Basics environment. And that's seems a little odd, right? So this is something that somebody might try to take malicious advantage of. Anyway, so what I would do now in this hands-on exercise, let me close my browser. What I would do now in this hands-on exercise is I would write down this IP address, 10.1.114.154, and I would list these open ports, 22, 80, 139, 445. And then I would go on and scan the next Nmap 10.10.120, 120.199. Scan the next host. This one has FTP open. Wow, so now I could say FTP 10.1.120.199. FTP command not found. FTP command not found. That's odd. Okay. Anyway, oh, I might have to install FTP. I'm not going to do that right now. But so I could use FTP to connect to that host, and I could maybe do a brute force password guessing attack to try to identify username password combinations that would give me access to that FTP server, and then I could rummage around and find stuff. FTP is a file server, right? So there might be interesting things in there. Okay, which IPs are running web server software? Well, any IP addresses that have port 80 or port 443 as open ports are running web server software. So I would list those. And then, okay, and then some references. Okay, so that's the end of the exercise. Basically, we used Nslookup, we used dig, we used Whois, and we used Nmap to do some reconnaissance and scanning of devices on a network. There's more information about Nmap in the man page or online or in the slides that I used last week. So the reconnaissance sort of lecture has info about Nmap and different command line switches and such. So that info is all available. Okay, and I'm going to stop there. So hopefully you have an understanding of this hands-on exercise and how you might use it in class and some talking points to go along with it. All right, so thanks for joining us this week. And next workshop will be next Tuesday at 1 o'clock.